Okay. Good morning, everyone. Our presentation today will cover the topic design of a reinforced lattice footbridge utilizing recycled concrete aggregate on Kangundo Road, Ruai. The presenters are Richard Saigilu and I. It was supervised by Dr. Gavimba. The first slide introduces the background of the study. Kangundo Road is a critical national artery linking Nairobi to the Eastern Bypass. This diagram tries to show the location of the section of our concentration. The rapid urbanization of Ruai has led to the high pedestrian activities. At the same time, the road experiences high traffic. There is high speed of traffic, including heavy commercial vehicles. Currently, there is lack of a crossing infrastructure, and our study proposes a grade-separated footbridge of 15 meters. In addition, the study explores the use of RCA as an alternative for natural aggregates. And from the previous studies, RCA has shown. From the previous studies, it has been shown that RCA can provide additional strength and durability when properly designed. Our study also considers a lattice structural design and examines the shear connection behavior of the RCA-based components as supported by the literature mentioned. Our problem statement. This slide outlines the This slide outlines the key problems that motivated our study.
Yes,
First, the study area experiences frequent traffic accidents and in some cases fatalities. Secondly, there is increased environmental pollution resulting from vehicle emissions and demolition waste generated from these construction activities. These negatively affect the air quality and the surrounding environment. Building a bridge to solve these issues introduces its own engineering challenges that must be overcome. So the third key problem is on materials and durability of RCA. RCA has variable qualities and higher porosity risks, and it compromises the integrity of a structure. Finally, we face a significant geotechnical challenge. The site has a consistently high groundwater level. This saturation weakens the soil, and it implicates the excavation and increases the risk of foundation. Our next slide talks of our study justification. As explained above, our project addresses two critical issues, that's the pedestrian safety risks and traffic congestion. To solve these, we propose the design and justification of an at-grade lattice footbridge. These will not only enhance flow and mobility improvements, but also showcase the sustainable applications of using RCA. The main objective is to design a lattice footbridge utilizing recycled material, that's the RCA. Our specific objectives include to conduct a traffic analysis to determine pedestrian flow patterns, to design footbridge components include girders, piers, and footings, and also to design the shear connections. Our third objective is to conduct cost-benefit analysis comparing the design with RCA and the design without RCA. Our research hypothesis questions include: why is the footbridge needed? We basically need a footbridge because there's currently lack of infrastructure and there are frequent accidents. Our second research hypothesis is: how will it be structurally safe? We will incorporate the lattice system, which will significantly increase the bridge strength. And is RCA a better choice? Yes, because one, it is cheap compared to the normal aggregate, and two, it reduces landfill waste and lowers the carbon footprint. Scope of the study. Our study area mainly focuses on Kangundo Road corridor at Ruai, specifically on a 4-kilometer stretch. And our road consists of a 4-lane highway with a 15-meter span length, and this is where we will put our bridge. And we'll also incorporate RCA properties from secondary data to design our bridge, and we'll use Eurocode 1 to 3 for our references.
Okay, I'll pick from there. We have the limitation of the research. We are saying that we will obtain RCA data from secondary data. We are not going to conduct any lab test on the RCA. Also, we'll have a limited traffic data collection, whereby we collect data traffic in a span of 2 weeks. We are not going to conduct like an yearly data where we're going to get sufficient data in there for analysis. We also, our design will be preliminary, whereby you're not going to do any geotechnical analysis, which is also crucial in the design of especially the foundation component. Then we are saying that in the design, we are talking about the shear capacity and the bond integrity, where we are talking about the bond between the concrete component, which is made up of RCA, and the superstructure, which is made of the lattice system, which is mainly the steel. From there, we have our literature review, where we have quoted, we have read like 4 books and more. We have obtained the critiques. From the author Sadiq, we had a critique of integration of behavioral activities of pedestrian in the design. Then from Ali, there is a limited application of footbridges of RC in the construction of footbridge. And then from one, we are saying that it talks about the connection, where there are limited, there are no long-term fatigue performance, the shear connection with RCA. Then we have Wahongo, talks about the feasibility rather than the durability performance of structural elements. Then from there, we have our gap now, as explained. We have limited research integration, RC application in pedestrian footbridge, and then we have the integration of behavior of pedestrian in the design of footbridge. Then we have the uncertainty of long-term fatigue performance of the shear connection. Then the final one, we have the limited field-based validation of RCA, whereby we are saying that the results obtained from the RCA performance are mainly based on the lab specimen. From there, we have our conceptual framework, which are based mostly on objective. We have the first, we have independent variables and dependent variables listed there. Then from there, we have our methodology. In our methodology, we will have 2 phases. Our first phase will include site and data analysis. In the site, we'll conduct a site reconnaissance, whereby we'll visit the area and conduct some pedestrian counts and observe the crossing patterns. Then we also do the pedestrian and traffic analysis. We'll conduct the traffic counts, speed, and composition. In our next phase, this will cover our second and third objective, which is material and design analysis. In the material suitability, we'll analyze the properties of RCA, of course, using the secondary data. And then We'll also assess the suitability of this material in the design requirement. Also do the structural designs, whereby we design the components that we have listed there, the piers, the footing, and also produce the drawings. And finally, we'll do the cost-benefit analysis. Here we'll try to compare the design which has incorporated RCN and the conventional design which has incorporated the normal cost aggregate. From there, we have our project plan as listed there. Then we have our budget, which sum up to 10K. And we have our references, and finally our last slide. Thank you. And apologies for the...
Okay, thank you. You have presented within the 10 minutes. Now, Dr. Winnie.
Thank you to the students for the good presentation. At least I can see you improved from the concept presentation. I've seen you added the issue of RCA. I have a comment. I think, I don't know, maybe justification first or problem statement. I'm not sure which slide. Justification or problem statement, one of them.
Hello.
Yes, please, the slide of justification or problem statement. Can you open at least one of them? The previous one? Yes, this one on problem statement.
Yeah.
You have a comment on the first two, frequent accidents and fatalities and increased pollutions. Can we have numbers of these values? You just don't mention without numbers in scientific research.
All right.
So please, let's have these numbers. Then you mentioned it, you may not have captured in writing, but you said that the RCA has improved strength. I heard something like that. Is that correct?
We said has comparative same strength as compared to the normal cost aggregate.
Is that true? Is that true?
Not sure.
You need to check probably literature.
Yeah, I was going on the next part, the literature review. No, the scope before you go to the literature.
Mm-hmm.
I don't know, it is a scope or the limitations. The limitations.
Limitations are here.
Yes. You said you'll obtain secondary data for the RCA, you will not go to the lab. And on number 2, you have limited traffic data collection. For the RCA, I will comment when I go to the literature review, the first one. The second one on the limited traffic data. Yes, of course, you'll have limited time. But I wanted to ask, this road is under which authority? Maybe they should have a lot of data on the traffic. Kera, Kura, Kena, I don't know. Which authorities, this road is under which authority?
Under Kena.
Don't they have data? Maybe you can check if you can get the data from them.
All right.
So the next, on the first one, on the secondary rounds of data for the RCA, I hope you should have shown that in the literature review, that you show what previous researchers have worked on RCA and what are the values. I wish you have shown that. You had shown that then.
Yes, you've captured.
If you have not shown, I believe you have that work in your proposal document. But I have a question on the same. If these RCA from different, I believe you are getting it from, each RCA get it from a demolition site. Are the properties from one site the same? Can you adopt the same in your design? Like if a building was demolished elsewhere, will the properties of the RCA be the same from 2 different sites? Just think about it as you adopt it in your...
Take note that point, Richard.
As you adopt it in your research. Those are my major comments. Thank you.
Okay. Thank you, Dr. maybe just before Dr. Kadimba comes, I would ask, were there some previous comments from the last presentation? And
Yes, yeah.
that before.
Yeah, we were told to rephrase the wordings of our topic.
Okay.
Using the word incorporating
Okay.
to utilizing recycled concrete aggregate.
Okay, next.
We were told to increase page numbers. We did that.
Okay.
We were also told to rearrange our objectives 2 and 3.
Okay.
And also to include the objective on cost benefit analysis.
Okay, next.
We were told to present and not read, in short, summarize our presentation. That's what we did.
Okay.
And we were told to add information on RCA, on our background information, and also add it to our references.
Okay. Any other comment which came before?
No other comment.
Okay. Great. So you need to note the comment from Dr. Winnie. I think you can have a table of a number of studies, maybe talking about RCA, maybe like around 5 studies. And you use those ones to address the question of the source.
Okay.
Thank you. Dr. Gadimba, I'm aware you are the supervisor, but just in case you may have a small comment for them.
Yeah, thank you, Chair. Looking at the third objective, you might not be able to exhaustively cover objective 3, cost-benefit analysis. So you remove the word benefit, you talk of cost implication. Because we're just going to get the cost of materials, right?
Yes, yes, yes.
Cost benefit analysis is like you're going to analyze what is the benefit of that structure to the community. You are not going to do that. What is the benefit of that to the society? You can't do that. Okay?
Okay.
It's just cost implication. Okay.
Okay.
Then the other thing, maybe a small one. I don't know. The others we can look at them later. But I feel there is, for the sake of other people who might be listening to it, the phrasing of your first objective to conduct the traffic analysis. You are conducting that's a method, so it's better to say to determine pedestrian flow patterns through traffic analysis or traffic studies. Now,
Not that comment.
Research hypothesis.
Yeah.
Hypothesis, you need to look at that. I think you might not have understood from theory of structure. I mean, sorry, from research methodology, what are hypotheses? These don't sound like hypotheses. This seems like research questions. And even if they were research questions, they are not, are they related to the objective? Because they should be related to directly to the objectives. Okay. So look at this slide.
Okay.
The rest I've noted them down. Of course, I'm going to pass them to you. Thank you, Chair.
Okay, thank you. Mute your mic. Mute your mic and mute your mic.
Okay.
Then stop sharing. The next group, who is here? Byron. Hey. Byron Abor.
We are available.
Okay.
Mic test. Can you hear us?
Yes.
Okay.
Please, we don't have time, kindly. Share your work.
Can you see it?
It is not clear. Yes, but there's something there.
What about now?
Why can't you remove that screen? Yeah. Now it's okay. It's better.
So welcome to our project. The project is about performance of Styrene-Butadiene-Styrene modified asphalt mixture with polyester fibers under water and chemical damage. So the introduction part. So asphalt pavements are vital to modern infrastructure but are prone to rapid deterioration when exposed to moisture and aggressive chemical environments. Water infiltration weakens the bond between bitumen and aggregates, while acidic rain and silent conditions accelerate the structural damage. To enhance durability, modifications using Styrene-Butadiene-Styrene, which is SBS polymers and polymer fibers, have demonstrated significant benefits, including improved elasticity, adhesion, and chemical resistance. SBS derived from styrene and butadiene enhances asphalt performance by increasing high temperature resistance and low temperature flexibility, giving the susceptibility of unmodified bitumen to acidic corrosion. This study investigates the performance of SBS modified asphalt under acidic conditions. So these are SBS pellets. So the main objective is to evaluate the performance of SBS modified asphalt mixtures with polyester fibers under chemical and water damage conditions. Go to the specific objectives. The first one, to evaluate the effects of polyester fibers on the indirect tensile strength of the unmodified asphalt mixture. The second one, to determine the effect of acidic conditions on the stability and volumetric properties of the asphalt mixture prepared from SBS modified asphalt polyester fiber. The third one is to determine the stripping value of SBS modified and plain bitumen at different pH water solutions. This is the scope of the project, what the study can cover. So these are the asphalt and the SBS pellets and the physical appearance of the SBS. Yeah. So the project investigates the performance of SBS modified asphalt reinforced with polyester fibers through a comprehensive evaluation of mixed designs, mechanical strength, and the durability under acidic, saline, and variable pH environments.
Please present. Stop reading.
Okay. So the microscopic analysis will be conducted to examine binder interactions, helping improve the structural, the chemical and the chemical and acidic. Yeah. So the study justification, it addresses the challenges of pavement's deterioration prematurely from chemical water damage by combining SBS polymers with polyester fibers. Asphalt can be made stronger, more stable, and better at resisting harsh conditions. The findings will help create pavements that last longer, are more cost-effective to build and maintain. So the literature review. So we have 4 slides. So let me read the first slide only because of time. So the outcome, that one, study area, asphalt, adhesion, and chemical theory. The performance outcomes showed electrostatic and chemical bonding mechanisms. Acidic alkaline water alters rate of potential and weakened adhesion. So what the previous author wrote in the correlation with our current project is it supports the need to evaluate asphalt performance under different chemical and water conditions. Let me read the second last one. The author Waizang of 2024 saw our references at the current from the past 5-6 years. So what she studied is the effect of water pH on asphalt binder and aggregates. And the performance outcome for this her project was acidic and alkaline environments alter zeta potential, binder chemistry, and adhesion. Acidic water worsens stripping. Stripping is the loss of the adhesion between the aggregates and the binder material. So what it correlates with the project is directly relevant to studying acidic water effects on SBS modified asphalt. So if it is okay, I can just leave it there, then I can proceed to the research gap. The performance of SBS fiber reinforced asphalt in realistic acidic rain conditions, such as those reported in Nairobi, remain understudied. The second one, most existing studies focus on moisture damages, neutral water, not acidic or alkaline environments. Third one is limited research examines SBS modified asphalt under chemically aggressive water, especially varying pH levels. The fourth one, most existing studies do not investigate the rate of degradation over time when asphalt mixtures are submerged in low pH level solutions. So we proceed to the methodology, which I'm going to leave to my partner. We're going to proceed. From the methodology, this is our logical framework, from theoretical execution to the result analysis discussion. So on the research design, comparative study between SPS modified asphalt mixtures with polyester fibres and unmodified asphalt mixtures. Our focus here will be the performance of this mixture, this new modified SPS mixture under acidic water conditions of less than pH 3 and less, and the mix design conducted to determine optimum bitumen content. These are the equipment that we'll be using and this is the Marshall testing machine, and this is the indirect machine, and this is the asphalt stripping valley machine. And our materials here will be granite from Georgia Quarry, graded by the Kangundo Road design manual, and our bitumen conventional ratio is 67 penetration grade applied by the Industrial Stream Limited. We've used water, distilled water for stripping tests and acidic solution preparation from Georgia here water. And sulfuric acid, we also need sulfuric acid to prepare the acidic water of less than pH 3. We'll be needing the polyester fibers in specifically for 18 millimeters in length, and it will be melted to 240 degrees Celsius. We'll be sourcing this from Kalyani polymers right here in the wheel, and then final material will be the Styrene-Butadiene-Styrene recycled polymer purchased locally. So we're going to our specific objective here is to evaluate the effect of polyester fibers on indirect tensile strength of modified asphalt.
Mwambie nitumie till, naona mpesa yangu haina pesa. Mwambie nitumie till nilipe na kuya duka.
Pictures, and our expectation would be to improve the tensile strength performance of the asphalt, and also to enhance crack and moisture resistance, and finally to identification of optimum fiber content inside. So under the indirect tensile strength, what we'll be measuring here is that this machine determines the tensile strength of asphalt mixture and resistance to cracking under traffic loads in moisture conditions. So we'll go to our next objective 2, is to determine the effect of acidic conditions on the stability and volumetric properties of the asphalt mixture.
Okay, what
prepared
about
from SPS modified asphalt with polyester fibers. The materials we've seen, as mentioned earlier, and our expectation here will be to increase the Marshall stability and load carrying capacity of the asphalt, and also to improve resistance to rutting and permanent deformation of the road. The third one is optimization of fiber and SPS content. So in Marshall test, there are two machines that will be measuring the Marshall stability. This tests the maximum load of asphalt specimen that can withstand before the failure of it, and also we'll be testing the Marshall flow, the specimen that undergoes at the point of maximum load, as you could see from here. This image here, this is what we'll be using to test our specific objective 2. Then our specific objective 3 will be to determine the stripping value of SBS modified and plain bitumen at different pH water solutions. So our expectation will be to reduce the stripping in SBS
defined upon durability. As we all know that what stripping value means is the loss of relation between bitumen, SPS, and aggregates when exposed to water under different pH values.
Byron, observe time.
Yeah, so this is our project schedule. I'm finalizing the study, and this is our budget, and then this is our reference. Thank you so much for your time and patience.
Thank you. Thank you.
Yes, I'm inviting any questions kindly.
Please, before you invite questions, tell us what were the previous comments and just quickly, how did you handle them? Quickly.
Well, our previous comments were the arrangement of our slides. They say, as you can see, this is the updated version. It's more clear and less wording.
Quickly.
Yes, and our specific objective was to be arranged in this format, this new format, as you can see here. So those are the only comments from the last presentation.
Are you sure?
Yes.
Was your topic accepted?
Yes, it was.
Okay.
Yes.
Thank you. Thank you, Dr. Gadimba. Something for them?
Thank you,
Dr.
Chair. Thank you, Chair. Byron, it was a bit difficult to follow your work. It was surprising. Some used before.
The people are using now the common fiber, the eggshell. So this the SBS is a polymer. Yeah.
I mean, did you review that? I was looking for that in the background. Your background. You mentioned about other materials that have been used before.
Noted, but in our main report, we're going to highlight that.
Yeah, that's why it was a bit difficult even to get what problem and the gap that you are addressing. Without that, then it becomes a bit vague. You might just think you are doing work maybe which is already existing with no foundation or backing of past or previous studies. So that's a very crucial part.
Well, from the previous studies, they have only used the SPS polymer, not separately like us using it with the polyester fibers. So from previous background, they've only mentioned about the SPS alone, without including the polyester fiber. This is why our research is now unique in that way.
Now, yeah, that should be there in the background and the background literature review. Your background. Because there are two areas that people confuse. The way you introduce your problem in the background will help us now understand your problem statement. Okay. So at the problem statement level, by the time you are stating your problem, it means you have introduced it. I'm able to understand what it is that you are addressing. Now, the research gaps result from detailed literature review. Okay. Well, both of them, they are trying to show us the problem you are solving, but you can't say I didn't include it in the background, it's not there, but then you state the problem statement. Where did the problem come from? Okay. So those things.
It's right there on the research gap, the second point.
No, I'm talking about now the problem statement. I was in the problem statement.
Okay.
The introduction that you gave that led to the problem statement is very important. I should read chapter 1, and without going to chapter 2, I should be able to understand the problem that you are addressing based on how you have presented your introduction. Okay.
Okay.
Now, can you read for me objective 1? Because I didn't see it. I couldn't read it.
Objective 1.
Yes.
Yeah, our specific objective 1 is here.
No, not that one. Can you go back?
This is our objective 1. The main objective, or this is our specific objective 1 to evaluate.
Byron, this is the methodology. Please go to the objectives.
Yes, you are confused. Yeah, What is there at the bottom? The one here. What is written there? Are we supposed to know what is there down?
There's additional information because it's paid.
Oh, it's additional because I was trying to read it. Understanding
how these enhancements influence strength, stability, adhesion, and overall durability.
What is that?
That's a disaster. That is font size 8, eh? In a PowerPoint.
Why do you have it there?
Pardon? Wait.
Why do you have it there?
So we're going to the formatting. Sorry for
Dr. Continue.
Okay, the next one. Okay, okay. I thought it's part of the objective. That's why I was asking. Eh?
Oh no, it wasn't part. The main objective was.
So please, don't torture us, please. Okay.
Okay.
Yeah, we'll be checking that when you are presenting. You know, that's why I was telling you, with the challenge now of following the presentation, it becomes difficult to concentrate on the content. So there are a number of areas that we could have assisted you, but now it's difficult. Eh? Anyway, I hope to see an improved version when you are presenting your progress next semester.
Okay.
Thank you. Before Dr. Winnie comes, Byron, I think Byron and the partner. Who is your partner?
Elias.
I think there was a time I was meeting you and you complained that your partner is not available. So I wonder if he's part of your team.
It's part. We actually here together. It was only that day.
You are bribed.
So
you are held up.
Yeah, the supervisor is leading us to Dr. Winnie.
Have you been seeing her?
Yeah, 4 times.
4 times?
No, a couple of times, 3 times actually.
Are you sure these slides, did you share with your supervisor these slides?
Yeah.
Huh?
Yeah.
When did you share? You shared today or when? Yesterday, what time?
Early in the morning.
Early in the morning?
Yeah, and then we discussed over it.
So this actually, this one is an updated version of the one you sent her yesterday. And we made improvements from the one which is she has.
Thank you. What were the previous comments?
About how we planned our literature review. Yeah, the previous one was
okay. Any other comment?
Also, how we're going to the research methodology, and how we are going to plan it, and what the expectations from.
So what did you change?
So we added these expectations from.
You added the expectations.
Yeah, it wasn't there. We had only.
It wasn't there.
Procedures. Yeah. Procedure of how to determine the stripping value and determine the effect of acidic conditions. So we added the expectations on what we expect at the end of this research.
Anyway, please, you should be consulting your supervisor. You have not, I'm sure you have not been seeing your supervisor. Now, general comment, your slides are very busy. They are very busy. Why? Until I had to stop the gentleman from reading. Under the introduction, they were very busy.
Okay.
Go to the introduction. Yeah, look at this. What is this? Elias.
Yeah.
Is this how we do slides?
So we tried shortening the introduction part, but
you mean with this one you left some things out?
No. So if you were to shorten the introduction part, we would have left some crucial and important information.
So we tried as much as possible to.
So this is the best. So this is, we need to expect even next semester you will present this.
No, we will come into, we'll update, of course, in some more research.
This is poor. Your slides are wordy, and you are aware we have commented this from before. The other presenters, we were commenting when their slides were busy. We said so, and I'm wondering why you had to repeat it here.
It's only on the introduction part, but these other ones, I think.
Go to slide number 5. You
Yes.
can see that slide.
Yes.
You can see it is busy.
Yes.
Why?
The images and this one to explain what these are. Yeah.
Okay, you are still defending. Your organization is bad. Look at the main objective.
Yes. Yeah, yes.
What comes after the background information? Is it main objective or problem?
The problem statement. It's the problem statement.
So organization is poor. Again, your slides are not numbered.
It is numbered here. Can you see this? This is number 3 here.
Which font is that? Font height.
Yeah, we'll expand it more next time.
Your slides were not numbered. Some are not numbered, like number
15. They are all numbered.
Number 15. Let's go to slide number 15. And see they are not numbered.
It is numbered actually.
Thank you. Now look at this. What is this you're trying to show here? What are these lines?
Which one?
No, number 15 slide, the so-called number 15, slide number 15. What is this? What are these lines? The lines.
This is part of presentation, PowerPoint slide, but the numbering of the pages right here at the bottom.
Why were you choosing this kind of presentation of the slide? What is the importance of those lines?
We'll have to improve it next time. Okay.
Well, there's no next time, Byron.
Yes.
Kuna mambo ya next time ni sahi. Okay. Please note that.
Yeah, thank you.
And your slides were not numbered, and I'm sure you need to see your supervisor more often.
Okay.
Yes.
Noted.
Thank you, Dr. Winnie. I'm aware you are the supervisor. Maybe you may have something for them.
Okay, of course. First of all, thank you to the other panelists for the comments, and to the students. When the panelists give you comments, it's not a time to fight back. They are here to help you improve your work. So you should take these comments and use them to better improve your work. So as they commented, of course, I told you yesterday when you shared with me your slides, and I told you to improve them. I don't want to see this work in the presentation. But of course you brought it, and you said you shared with me, so that it's like I approved this work. Of course your slides are too busy, and you make the panelists not give you the enough comments to improve your work. So next time, please make your slides as good. Like you saw, you were here from the beginning, you saw what the other students were presenting. Their work would flow, there was flow, and they were able to be given comments. So please, if you make your work to be good, you give the panelists easy time to give you guidance so that you can improve your work. We are not here to fight with you. We are here to help you improve your work. So let's continue working together, and please, when you're trying to work on something, make sure you do that. Thank you.
Thank you, Daktari. Thank you, Byron. Mute your mic.
Thank you.
Byron, mute your mic. Then you stop sharing. Mute your mic. Thank you. Next, we have Odongo and Emma.
Yes, we are here.
Please, we don't have time. Kindly share with us your work. We have less than 10 minutes for you. Okay, we can see your slides.
Okay,
Thank
good.
you. Thank you.
Good morning. So our research is on influence of recycled tire steel fibers on flexural behavior of reinforced concrete beams containing expanded polystyrene, and the presenters are Odera Charles Odongo and Undisa Prudence Emma. So on the background, so due to increase in population, we need more infrastructure, which require concrete to build, and aggregates are an important ingredient in concrete. So aggregates are extracted through quarrying, and heavy machines such as excavator, they use fossil fuels. So incorporating recycled materials, i.e. expanded polystyrene beads to partially replace aggregates makes concrete production more sustainable, and in the long run, it will reduce the dead load. It will also improve thermal insulation, and it will lower the cost of foundations. EPS reduces compressive and tensile strength and increases brittleness of concrete. Steel fibers can help in enhancing tensile strength and also in crack control. We are now focusing on steel fibers from recycled tires, which will address EPS drawbacks on the reduced flexural strength behavior. Moving to the problem statement, EPS usage has been studied from previous papers. EPS-based concrete is lightweight, but reduces flexural strength and stiffness and ductility, and this will limit its use in beams. Steel fibers from waste tires could enhance crack control, load capacity, and post-cracking behavior. So locally, there's limited evidence on the effectiveness in reinforced EPS beams. We lack data on how EPS inclusion and fiber dosage affects load deflection, cracks, and this gap hinders design guidance and adoption in our construction industry. So why this study? Waste tires are an environmental nightmare. We reduce usage of virgin steel and carbon emission if we recycle them. They will counteract the strength loss to enable structural use of EPS concrete. So we are aiming for structural grade flexural strength of over 5 MPa. Our aim is to investigate influence of recycled tire steel fibers on flexural behavior of reinforced concrete beams containing EPS. And the specific objectives, these are our specific objectives, which we'll discuss in the methodology. Yeah. The scope of work is experimental, focusing on recycled tire steel fibers being incorporated into EPS-based concrete. Dosage of EPS will be chosen from Salah Al-Din's work, and from this we will develop a mixed design and prepare specimen to subsequent tests, such as slam test, cube test, and 2-point load on beam, then data analysis, and then we'll draw conclusions. For study limitations, field variability is not addressed because the research is lab-based. Our data analysis will be based on 28 days, so we won't take keen on long-term properties such as durability. And then RTSF will have irregular geometry and will be coated by contaminants. Aspects such as fire resistance will be excluded since we are focusing on flexural enhancement. Then high RTSF content could lead to clamping, but we will assume uniform fiber distribution. Yeah. And then on the literature review, so different we've looked at different research papers and picked Salah Al-Din. We are focusing on Salah Al-Din's work, so that's where we're going to get our secondary data. So he was talking of effects of adding EPS at different dosages, 20%, 40, 60, 80, 100%, and major drawback was sharp drop in flexural strength at 40%. EPS will be constant, so he'll be our source of secondary data. But we also looked at the rest. You can continue, please.
Yeah, so we also looked at other papers, and as you can see, most of our critics, like for example, for this Rajeshwaran, he had EPS but no fibers, and for this one, he had EPS but no fibers. Okay, he had no fibers but he had EPS. He had no EPS but had fibers. For here, it was just stranded concrete without the fibers or the EPS. So with this one, they incorporated new fibers, but not the recycled tire fibers that you're using. And as you can see, most of them ignored the loss in the flexural strength of this EPS concrete. So our research gap, as you have seen, will be tackling a gap in which they have not tackled the loss in strength and the increase in brittleness of this EPS concrete. And of course, there's limited study in the RTSF inclusion in EPS concrete. So moving on, we came up with a conceptual framework where we have the independent variables and the dependent variables. We divided them into three. Under the material sections, we had the cement, fine aggregates, EPS, and RTSF, which will affect the workability in the dependent side of the variables. We had the things that will be varying, which are the RTSF, but for EPS, it will be constant. This will affect the density, compressive strength, and the split tensile test, the split tensile strength. And on the third section is the specimen, whereby it will give us the values in dependent variables for the load deflection curves, ultimate load carrying capacity, crack patterns, etc. And coming to the methodology, what materials will we be using? We have cement, as you can see, aggregates, the EPS beads, and of course the RTSF, which is what we are bringing in. So on our methodology, we've divided it into three. The objective one, which was the characterization of the constituent materials. Objective two, the mixed design and checking the workability and the mechanical properties. And on the objective three, it's about the beam. So the fracture tests and of the reinforced beam with the EPS, with the RTSF. So on the objective one, material characterization, we will do some tests on cement, on the aggregates or RTSF. For instance, on maybe the aggregates, we have to do the density, water absorption, PSD, which will give us the properties of these materials. Going to objective two, which is the mixed design and fresh properties, we'll do the slump test after mixing the varying percentages of RTSF and give also the fresh density of this nini. And then we'll also do an oven dry density after doing the wet density. And under still the objective two, we do the hardened mechanical properties there, but we'll do the compressive tensile, the compressive strength and the splitting tensile strength, and the formulas are indicated as I have shown. And we go to the objective three, which is about our beam. We've displayed the beam there, and what we'll be doing is testing the beam for the flexural strength of the beam. The formula has been written there. The parameters are as illustrated. So after the test or doing the test, you take photographs and all those so that you can assess the crack, the mode of failure, how it is happening, and we'll measure the width of and the spacing of the cracks, which will add up to give us our data analysis. From the data, we'll be able to plot a load deflection graph, which will gauge the ductility and the toughness of this RTSF concrete beam. And the expected outcomes, of course, we'll be able to characterize by the end of the test, you'll be able to fully characterize the materials, know the effect of varying percentages of APS on beam, and the flexural behavior of this EPS. So our work plan, as you can see, we've already done, we are at literature review and final proposal part, and the rest are as shown. And our budget is at 10,000, whatever will cost us with the cement, EPS, and steel fibers. These are our references that some of the references that we use. And thank you very much.
Thank you. Now, what were the previous comments on the last presentation or proposal, the concept?
Dr. Mutungi raised issue with the specific objectives that they were not clear.
Go there.
Yeah, then Dr. Mutua told us to add the visual diagrams for the beams. Which is here. How we are going to do it. Yeah.
Next, the other comment.
Then you talked about our novelty.
I talked about it. How have you addressed it?
From whatever we've just shown you, everything is now clear. There is no storytelling or anything that is making things unclear for those whom we are presenting to.
So thank you. Dr. Winnie.
Thank you very much for the presentation. On the literature review, I will tie to the methodology. You said for the EPS, you will use a dosage which has already been formed by the first order. Is that true?
Yes, yes.
Is one order enough for you to give you a amount to use in your research? Did you find other orders, and what percent? Did they give a similar percentage?
Well, they had different percentages, but we picked Saladin because they have not used other admixtures and different things in their mixes. So they were just trying to look at the EPS, how the EPS affects concrete when it's incorporated to replace aggregates.
So that's the only order you found using EPS alone?
Yeah, well, we have different authors, but we picked Salah al-Din and Hadithi because we don't want to, our EPS will remain constant. So we are not changing.
I'm not confusing that you found that order. I'm just asking.
What she's trying to explain is that, for concrete, there are always admixtures. But in Saladin's case, they used concrete as it is, but added EPS to replace the coarse aggregate partially. That's why we found that suitable. And in addition to that, Saladin had done tests to do with the flexural strength, the different percentages that incorporated for EPS, and gave a clear view on the effect of EPS to do with the flexural strength. So that was even a more clear research to use.
Thank you for that. What I mean is, yes, you are adopting that order for your optimal percentage of EPS.
Yes.
It's good to try and see if we have another order who gave another value, and see if the value is the same, because as for you are just going to adopt it. So when you're adopting it, you need to have some several literatures which have all of them zeroed on that amount, that percentage. You understand?
Yes.
Please try to look at other literatures. Then on the methodology, on let's see the first one, the first objective. No, on the methodology, how you are going to tackle the first objective. It's characterization?
Yes.
Okay, I wanted to see whether you had something on the steel fiber. It's okay. Then on number 2, objective 2 on the methodology, I didn't see how much dosages, since you are going to adopt for the EPS,
Mhm.
I didn't see the percentage you suggested for the tire fibers.
They will vary.
Yes, those percentages, you need to indicate them to show us how much you'll be varying them.
Okay.
Okay, thank you.
Thank you.
Thank you. Uh-huh. Dr. Gadimba.
Okay. Yeah. Yes.
Okay. I used 24. Well, this is 28 because we wanted it to fill, but majorly you've used 24. For the titles, you've used 30.
Yeah.
Mhm.
Yeah.
Thank you. Uh-huh. Mute your mic and stop sharing. Who is coming next? 0318.
Yes,
Thank you. The floor is yours.
thank you. So this is a topic, flexural performance of concrete incorporating coconut waste fiber and firewood ash as a supplementary binder. Presented by Tony Chaka and Michelle Wanjiru, supervised by Dr. Naftari Gadimba. Concrete is a widely used construction material, and concrete is of brittle nature and low tensile capacity, so it needs to be reinforced to meet the design criteria. There's an increase in natural and biomass waste, and cement is costly. There's an advantage of using firewood ash and coconut fiber and concrete. Background information. The early cement hydration produces the calcium silicate hydrate and excess calcium hydroxide, while the firewood ash reacts pozzolemically with the calcium hydroxide to form calcium silicate hydrate and calcium aluminate hydrate. Thereby, it will improve the strength and durability. But this reaction will not remove the calcium hydroxide completely. It will be left, but in little amounts, in which it will interact with the treated coconut fiber, which will lead to the enhancement of fiber matrix bonding at mid alkalinity and increase surface roughness, and also preserve the fiber strength and crack bridge ability. The problem statement: the concrete cracks under the flexural loading, and the treated coconut fiber will deteriorate over time due to the excess calcium hydroxide. The firewood ash alone does not consume all the calcium hydroxide, and the separate use of the two will fail to balance the benefits of the long-term material performance of the concrete. Justification: the high cost of cement the availability of natural and biomass waste, in which in this case is coconut fiber and the firewood ash. The treated coconut fiber will degrade due to excess calcium hydroxide. The firewood ash does not remove all the calcium hydroxide, and combining the two will help control the calcium hydroxide level. The study will promote sustainable use of waste materials, and also it will be beneficial in terms of environmental. There's low capacity, low cost, and it is eco-friendly concrete production. The main objective: to investigate the flexural performance of concrete incorporating treated coconut waste fiber and firewood ash as a supplementary binder. The specific objective is to determine the basic material properties. Objective 2 is to determine the mechanical properties of concrete, and objective 3 is to investigate the flexural strength of the fiber wood ash and the firewood ash and coconut fiber reinforced concrete beam specimen. The scope of the study: 4 beams, specimen 150 by 150 by 500. The content of the beam: it will have coarse aggregate, fine aggregate, the cement, the firewood ash, and the fibers. The 3 cubes specimen 100 by 100. The cylinders will be 100 by 200. The compressive strength test 7 and 28 days. The limitation of the study: the long-term durability not adequately investigated, the quality of material may vary, and also the field performance not examined. Limited advanced microstructural test. The literature review: the study area and the key findings plus the critiques. In sustainable concrete, commonly uses the supplementary cementitious material like fly ash and slag, but firewood ash is rarely studied in terms of optimal replacement levels and chemical behavior. In the natural fiber concrete, the fiber reinforcement improved ductility and crack control, yet the influence of concrete pore chemistry, especially the calcium hydroxide, on fiber durability is often ignored. In the wood ash concrete, the wood ash shows potential as partial cement replacement for sustainable concrete, but long-term durability effects are largely unaddressed.
For the next literature review, treated fibers may improve concrete mechanical performance, but the durability mechanism in terms of the chemical degradation is not fully explored. The SCMs improve durability. Though focus is on the well-knowns like silica and slag. The study is normally done on hybrid steel fiber reinforced concrete with fly ash levels. The focus is on steel, but limited on natural fibers. Treated coconut fibers improve tensile and fractural performance, though the study does not need concrete chemistry with fiber performance. This is our research gap. Focus on biomass derived SCMs like firewood ash overlooked. Limited attention to firewood ash in terms of chemical behavior. Limited study on hydration chemistry changes, effects on treated coconut fibers, long-term durability. This is our conceptual framework. This is the methodology. The experimental procedure: coconut fibers will be treated by washing and soaking in fresh water for 24 hours at 20 to 30 millimeters fiber length and air drying before mixing. Stage 1 is here we'll keep from the literature review. We've settled on 0.7% volume of concrete to be kept as the content of the fibers. Firewood replacement will be 0% control, 10%, 15 and 20% for them in the cubes and the cylinders. Then we'll select the optimum fiber content. Stage 2, the optimum fiber content that we have will be kept constant. Then we'll vary the fiber then selection of the optimum firewood ash replacement. This is the objectives: fine aggregates and cost sieve analysis, firewood ash and treated coconut fineness that for the firewood ash, the ones that will pass through the 75 micrometer sieve, coconut fibers, water absorption tests for workability, cement, consistency and setting out, concrete slump test and concrete mix design for the cubes, the compressive end, and for the cylinders, the split tensile test, beam specimen, flexural strength test. This is the expected result. All materials used will show good basic properties. Mechanical properties of concrete will be improved. Flexural strength of the fiber reinforced concrete beams with firewood ash as a partial cement replacement will increase. This is our project schedule. This is the budget. It's 10,000. The reference. Thank you.
Thank you.
Okay, let me comment. Maybe Dr. Odero is up. First of all, I think I liked how you brought the issue with the two materials. What is the weakness of each material and how you want to improve? That way you are showing a good reason why you are using the two materials. I think that is commendable. The comment or clarification is on the methodology on the objective two for the methodology. Please go there. Okay, determine mechanical properties. Maybe the next one where you are mixing the materials. The next slide.
Okay.
Next one. There was one you are showing the percentages.
Oh, it is here.
How you are going to vary the fiber, then now go to the ash. Yes. This one.
Yeah.
Yeah. I wanted to understand what will happen.
Pardon?
I wanted to understand, just summarize for me this work. First, we will keep the fibers constant.
Yes.
What did you select? 0.7%?
From the literature.
Okay. So first you keep constant, then you vary the firewood. Then you do the opposite.
Yes. This one we are using the reference from the literature review to find the firewood replacement percentage. Then after getting it, we now use that optimum firewood content. We keep it constant, then we vary to get our optimum content fiber.
But when you are in the first stage, when you will get the optimum firewood.
Yes.
It is not like the neat replacement of cement, because you already have the fiber in place. But anyway, fiber and ash are working differently, so I guess you can use. Okay, thank you. I wanted that clarification.
Okay.
I don't know whether Dr. Odero is back. Maybe Dr. Gadiba can continue.
Yes. Okay. Yes. 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 Okay. Justification. Okay. Yes. Yes.
From the literature review.
Oh. Yes. Yes. Yes.
And the rest of the calcium hydroxide is not left idle. It interacts with the fibers. It's called the
When
no, not a reaction, not a chemical reaction.
it's like you see when we add the firewood ash, it will minimize the excess calcium hydroxide, but it will not be fully eliminated. So the minimized calcium hydroxide will interact with the firewood with the coconut fibers, and it will improve the it will enhance it will enhance the fiber matrix bonding accumulated alkalinity, because the calcium hydroxide, when it is in excess, that's where there's the problem. But in this case, it will be in limited amounts, so it will lead to the enhancement of fiber matrix bonding when it interacts with the coconut fibers.
But if you are used
Okay. Yes. No, we are not using the calcium hydroxide to treat fibers. We are using fresh water to treat the fibers. We had indicated here. Just a minute. Yes, here we are going to soak it in fresh water. We are going to use fresh water to treat the fibers. Yes. Yes. Okay. Yes. Mm. Yes. Yes. Mm. Yes, but no, we are soaking them in. Yes. Pardon.
yes.
Yes. Treatment, I think it is, we are going to leave it overnight for 24 hours, so that if there's any difficulty. Yes. 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 Okay. Scope. The second objective. Okay. Mechanical properties of the concrete. Yes. Okay. Yes. 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 Okay. Mm. Noted, sir. Yes. Noted, sir. Okay, number 10. Oh, it is a continuation of the literature review. Oh, sorry. Oh, yes.
Just that. Thank you, Dr. Sorry,
Okay,
I
thank you.
stepped out. On this slide, look at the third last and the last literature. You are talking about East Africa material and Kenyan coconut fiber. Is that right? The material called East Africa materials.
No, it's about talking, the main focus in that book was East African materials.
Hmm.
Yes.
And all of them are from Kenya.
The
author.
Yes.
Okay. Check on that. I think check on the wording.
Okay.
Thank you. Dr. Winnie. Dr. You have commented or what?
My comments, sorry.
Yes?
I already gave my comments.
Oh, sorry. Okay, thank you. Mute your mic and stop sharing.
Okay, thank you.
I guess group number 13.
Oh, Nicole and Christine. Sorry.
Yes, let us share our screen.
Yes, there you are. You have less than 10 minutes.
Okay, good afternoon. I'm Christine and my partner's name is Nicole. Our project is on developing a prediction model for flexural performance of RCD beams retrofitted with sisal using secondary data, and our supervisor is Dr. Garimba. Background to the study. Our study focuses on deep beams with a shear span to depth ratio less than 2.0. Because they're deep, they don't bend like normal beams. They transfer loads directly to support through arcing action and straight and tie behavior. These beams are critical in infrastructure like transfer girders, bridge supports, pile caps, water retaining structures. However, they are prone to aging and replacing them is too expensive. That's why we propose sisal, which is locally available here in Kenya and is a sustainable strengthening method because it also has a high tensile strength. But because the beams behave non-linearly, standard engineering formulas and design codes don't work for them. Thus, we chose to use machine learning to develop a prediction model to predict the flexural capacity of the deep beams. This brings us to the problem statement. While deep beams are deteriorating, we face 4 major barriers. First is we can't handle the standard flexural formulas can't handle the nonlinear behavior of deep beams. Second, the existing studies focus mostly on slender beams. Major standards like Eurocode, ACI offer no provisions for sisal fiber retrofitting. And finally, there is currently no machine learning model to predict the capacity of this specific combination.
On objectives, the main objective is to develop a prediction model for the flexural performance of sisal retrofitted RCD beams, and the specific objectives are to analyze secondary data using experimental results on RCD beams strengthened with sisal fibers, and to develop a prediction model for the flexural capacity of sisal retrofitted RCD beams using gene expression programming, and finally to compare the predictive accuracy of the developed model to artificial neural networks and multiple linear regression. Onto our scope, our study justification is the flexural performance of deep beams is difficult because they do not follow linear string patterns of slender beams. Their behavior is highly nonlinear. While sisal fiber is an eco-friendly and cost-effective strengthening material, its specific application to deep beams is not yet well established in current engineering codes like ACI or Eurocode. By predictive modeling, we can systematically leverage existing data to improve the reliability of these assessments without needing a new massive experimental program. Our scope is to develop a
GEP prediction model for the flexural performance, specifically focusing on simply supported RCD beams defined by a shear span to depth, which is less than 2.0. And this study strictly evaluates beams retrofitted either externally bonded or near surface mounted sisal fiber techniques. Finally, our primary target output is the prediction of the ultimate load capacity based on the secondary data gathered. The limitations are because this data is a data-driven study, our model is limited by the quality and availability of secondary data. Additionally, while we are modeling flexural performance, the environmental durability of sisal fibers over long periods is outside the current scope of this predictive model. So a literature review. Sisal shows, we have the authors, the topics, the key findings and critiques in our table. The sisal shows significant improvement in flexural capacity and crack control, but it is primarily focused on slender beams and not deep ones. In terms of modeling, we are using GEP, which is simple but often fails to capture the complex nonlinear behavior of these structures. More advanced tools like ANN offer high accuracy, but the limitation is that they lack transparency and do not provide an easy use of equation for designers. According to the author Shah, the GEP is powerful because it produces interpretable equations that outperform traditional regression, yet it has rarely been applied to natural fibers or deep beams. In summary, we have information on sisal and information on deep beams, but the two have not been effectively combined in a predictive framework. And to the research gap, there is currently no existing predictive model designed to estimate the flexural capacity of RCD beams, specifically strengthened with sisal fibers.
So this is our conceptual framework within the independent variables based on objectives. To the research methodology, this is an overview. So based on objective 1, which was to analyze secondary data, we'll first systematically collect secondary data from major databases such as Scopus, Web of Science. The data size will be 50 to 100 specimens. Then we'll specifically look for deep beams that use sisal retrofitting and reject any experiments that failed due to error. And then from the selected papers, we extract the 3 categories of input variables, the geometric, material, retrofit properties. And then this inputs feed into predicting our target output, the experimental ultimate load capacity. Then we move to phase 2, and objective 2 was the model development. So before feeding data to the machine learning, we have to pre-process it. First, we normalize the data, scaling everything between 0 and 1. Then we partition the data into 70% and 30%. 70% to train the model, 30% to test the model. Then we develop the models. First, the MLR, which will be our baseline, and N to capture the nonlinearities of the sisal. Yes, and GEP to produce an explicit engineering equation. This will be our main model. Then to the next phase, based on objective 3, which was comparison of the models. To do this, we need to validate all of the models. First, we'll run a statistical evaluation using metrics such as R-squared and RMSE to mathematically prove which error rates are low. Then we'll verify visually using scatter plots. We want to see the model where the predicted points line up perfectly on the diagonal with experimental data. Then we conduct a parametric study. We test the equation to ensure it obeys laws of physics. Then to accept the model, we'll follow this criteria, and the model which is physically consistent and accurate will be adopted. To the expected outcomes, to conclude our study, we anticipate 3 deliverables. First is the data We will analyze data from different data sources. Second, we'll generate a practical design equation that engineers can actually use. Third, we expect to demonstrate superior accuracy, proving GP model outperforms other models. Then this is our work plan and our budget, 10,000, no references. Thank you.
Thank you. Thank you. Now, what were the previous comments and how did you handle them?
We were told to change our topic to be to focus more on analytical side other than the experimental side, and we were told to make our topic more investigative. That's why we are not assessing.
Okay. Next comment.
We were told also to focus on one natural fiber, which we chose sisal. Yeah, we chose sisal as our natural fiber.
Why?
Because it is locally available and has high tensile strength. Yeah.
Locally? Locally is where?
In Kenya.
So Kenya is local.
Okay.
Okay, thank you. Any other comment?
Yes, on our objectives, we are told to choose the second objective. We are told to focus more on one model other than the three, and then we use the other two to compare in the third objective.
Okay. Any other comment? Which was there before?
We were told to add more graphics and to make our slides less busy.
Okay, you have tried on that.
Yes.
Were there any other comment? Or that was it?
That was it.
Asante. Dr. Winnie.
Okay, thank you for the presentation. On the first slide on the topic, I wonder whether the last part on using secondary data is important. Just think about it. That last part on using secondary data.
Okay.
Using secondary data. Then I have a question on literature, but you can answer through the methodology on the objective one. Yeah, the methodology on objective one. Yeah, this one.
Yes.
Data mining.
Yes.
To help you get the values for using the model. Is that true?
Yes.
Have you already researched these literatures in your literature review? For this objective, because you'll use previous experimental data, then now you go to the prediction. Have you already done that?
We have not done that yet.
I hope I would have wished that would have formed also some part of your literature review.
Okay.
That is my comment. I had hoped you had done that so that you can maybe highlight on a few things, but I believe you'll do this because it is part of your methodology.
Yes, we'll do it next semester.
Not next semester. You don't have much time. Anyway, all the best.
Okay, thank you, Dr. Just on that, Christian, you have a lot of specimen. You're targeting 50 to 100. And if you're saying you have not begun, I think it is too late. You need to have begun on this because it's not just picking PDF and maybe copying. You need to synthesize the information from the documents that you are going to look at. And I do believe that is not a small work. It is quite involving. The data mining is not something that is very easy. So you need to start early and be able to have some good data which you expect in this work.
Okay.
Yeah. Yeah, that is it from my end. Yeah, Dr. Gadimba.
Yeah. Yeah. No.
You could make 2 slides out of this.
We already have 2 slides for the background to the study.
Out of this one slide, slide number 3.
Oh, okay.
It will spill to number 4 so that you explain these important figures here.
Okay. Yes. Okay. Yes.
Thank you. Mute your mic. Then mute your mic. Stop sharing. Asante sana. Next group. That was who? Nicole. Wallace and Alex. The floor is yours.
So our presentation was on the flexural and compression performance of concrete beams reinforced with recycled PET plastic fibers. The proposal was to be done by Wells Adair and Alex Mwangi under the supervision of Engineer Brown Odero. So on the background review, we found that the reinforced concrete is used widely due to its strength, but it's weak in tension and prone to cracking. So fiber reinforced concrete has gained a lot of attention as a means of improving the cracking control, the ductility, and the post-cracking behavior. So among the various natural fibers that we use, recycled PET plastic fibers can be obtained from plastic bottles. They can offer a sustainable and economical alternative. And these fibers, they can act as a reinforcement, enhancing the structural performance of the concrete. So still on the background review, this is the amount of, on the photo here, this is the PET plastics that we aim to use as plastic fibers. So on the problem statement, the conventional RC beams, they experience cracking at relatively low tensile stresses, leading to reduced durability. And so there's also plastic wastage and regularly the PET plastic bottles, which pose as a serious environmental change. So we are using the PET plastic as a recycled material to be used as fibers in reinforced concrete. So in the justification of the study, we are using the recycled PET plastic as reinforcement so that it can offer solutions that can improve crack control and the ductility of concrete. And there is also limited experimental research on the structural performance of the PET plastic in RC beams. And so the also outcomes will contribute to sustainable construction practices by improving crack control, flexural performance, and the reuse of waste materials. So on the objectives, the main objective, the general objective was to evaluate the performance of recycled PET plastic fiber reinforced concrete under compression and flexure. And the specific objectives were to determine the flexural strength of recycled plastic fiber reinforced concrete. Was also the second one was to determine the compressive strength of concrete with PET fiber as reinforcement. And the third one was to compare the performance of PET fiber reinforced beams with that of conventional RC beams. So the scope of the study will include laboratory testing of the RC beams under static flexural loading, also focus on the compressive and flexural strength test using the standard cube tests, and also the durability and the long-term environmental effects. So on the limitations of the study, there's a limited number of beam specimens due to time and cost constraints, and also the results may not fully represent long-term field performance, and there's also variability in recycled PET fiber properties. So as we go to the literature review, the main area of studies has been the use of fibers in concrete, but the main critique was this limited study on the use of PET plastic fibers in concrete as reinforcement. And also the second slide for the literature review also contains the same. And then on the research gap, from the literature review, we found there's limited studies on reinforced concrete beams using recycled PET fibers, and also the insufficient data on optimal fiber dosage for structural applications, which include the amount of fiber to be used in the RC beams. And also there's need for comparison between the fiber reinforced and the conventional reinforced beams.
On the methodology, from the first objective, which was to determine the flexural strength of recycled PET, we were to conduct a 3-point load tests, and these are the formulas to do so. And then on the second objective, we were to determine the compressive strength of the PET fibers as reinforcement, where we were to do sieve analysis, slump test, and the compressive strength test. We have the formula, and then on that objective, we have to compare the results of the PET fiber reinforced beam with the conventional RC beams. The expected results from the first objective were that the PET fiber reinforced concrete were to show comparable or slightly improved compressive strength. It was on the second objective, it was to show the fiber reinforced concrete is expected to show improved flexural strength, and the overall result will show that it can be possible to use the PET in construction. We have a work plan and the budget references, and thank you.
Thank you. Thank you. Now, I've been indicated as a supervisor. I want to ask you, what were the previous comments from the last presentation we had?
The last presentation we had to change, we changed the title completely because the other one was on 3D, which was said it was not easily achievable. So we changed the topic to using recycled PET fibers in concrete.
Let's go to the topic. So you changed to this topic.
Yeah, we changed to this topic.
Why?
We changed to this topic because we wanted to use the recycled PET fibers as reinforcement in reinforced concrete beams.
Why?
Or why the PET plastic fibers?
Yes.
Or the PET plastic fibers, they can't be used in beams because they are available. It's available from the PET plastic bottles, and also they are not prone to cracking, and they offer high tension stress.
Why?
Why the PET plastic?
Which other comment came from the previous presentation, or it totally changed?
It totally changed.
What is the motivation with this work?
The motivation with this work? The motivation with this work is that we wanted to use the other one was on...
No, this one.
Oh, this one. The motivation of this work was we wanted to use the...
Not what you want to do. What is it? What is driving you?
What is driving us towards this project? Because the material can be obtained, the PET plastic fibers, they can be obtained, and then can also be used as reinforcement for construction.
Is that what is motivating you? Because they can be found.
No.
And thank you. Your question answers the comment in the chat box. Yes. You can see what you have on the chat box.
On the chat box?
Yes.
Yeah.
I was expecting something different because I was asking about the motivation, something that is coming. Why are you doing this work? And I have not seen it coming. And from your response, it means that you can see that message.
From Dr. Gadimba?
Yes.
The effect of tetra. Yeah, I'm seeing it. I'm seeing it now.
You're seeing it now?
Yeah.
Yes, it means your work is not original. And that's why I was asking about the motivation. It is very shallow. It is showing that you just picked this thing from somewhere. And actually, PET has been done quite some time. So I don't know. Dr. Gadimba, could you just come in at this point?
No. No.
And openings.
Okay.
Daktari, you are muted. No, just now.
Okay. 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 Okay.
Thank you. Dr. Winnie.
Okay, I will not have much to say after your comments, both of your comments. But just the student, when you change the topic, you need to inform your coordinator, Engineer Karimi. So as they have mentioned, you really need to show your gap while you're doing this work. If the problem is not clear, we cannot see why you're doing this work, or maybe the work has been done. So please, as you're being advised, check on how you can get more gap. Don't run away. Don't go and get a third topic. Time is not on your side. But see what you can work still on the same. Thank you.
Okay, thank you.
Just like Dr. has commented on your title, the word compression and flexural need to be rechecked. Yes. And the fact that you have not done enough literature, we need a distinction between your work and what has been done to this point.
Okay.
Yeah. Thank you. Mute your mic. Mute your mic. Thank you. Next group. Who's coming next? Sally and
yes.
Oliver.
Yes.
Please, we don't have time.
Yes, we are screen sharing right now. Are you able to see our screen?
Yes.
Okay, good afternoon. And our project title is on the study on the structural behavior of container-to-container joints in multi-story shipping container structures. And I'm Sally, and my project partner is Oliver, and our project supervisor is Dr. Odero. So for our introduction, the rapid growth of modular construction has increased the interest in the reuse of shipping containers as primary structural elements in residential and temporary buildings. And although shipping containers are designed to carry significant vertical compressive loads, the original design was for temporary stacking during transportation rather than permanent use in buildings. And when containers are stacked to form structures, load parts differ from those used for transportation. The joints for container structures are subjected to dead loads, live loads, and horizontal loads from wind and seismic action. And depending on the connection method, joints may behave as rigid or semi-rigid. The studies focusing mainly on container joints are limited, and our study will focus on the structural behavior of container joints. For a problem statement, the current research on container construction focuses on the strength of individual shipping containers, while joints receive comparatively little attention, and the design for shipping containers is for cargo transportation, and when repurposed for construction, the joints are subjected to different loading. And for study justification, there's limited research on the joint behavior, since most studies focuses on the container as a whole, and also the increased demand for rapid, cost-effective, sustainable construction solution has led to the widespread adaptation of shipping containers as modular building units. So for the scope of our study is the structural behavior of container joints in multi-storey shipping containers, with emphasis on load transfer mechanisms, stiffness characteristics, and the stability performance. And the limitations for this study is that the long-term performance of joints are not considered, and the study does not include experimental testing. It focuses mainly on software. So our main objective is to carry out a detailed study on the behavior of container-to-container joints in multi-storey shipping containers using software. And for the specific objectives is to analyze and compare different types of container connections, to evaluate the effect of container joint design and bracing systems on the horizontal stiffness and slenderness, and to determine the maximum safe stacking height of shipping containers for residential construction. So for a literature review, we read on the modular steel construction system, and we realized that the study focuses on general modular systems and not the container joint behavior. And we also read on structural performance of container buildings, and we realized the study does not investigate joint behavior under lateral loads. And we also looked at container-to-container joint connection, and we realized that there was no comparisons of different joint types. And we also looked into connection behavior under cyclic loading, and we realized the study has not investigated container joints. We also looked into modular system suitable for low-cost housing, and we realized container joint analysis was not studied. So our research gap is that there's limited analysis of container joint behavior. There's limited studies linking joint design to lateral stiffness and slenderness. There's limited systematic evaluation of safe stacking height. And this is our conceptual framework.
Methodology. For us to achieve our first specific objective, which was to analyze and compare different types of container connections, we are first going to do modeling of our container structure, multi-story up to like 5 floors. We are going to do different types of connections, which we're going to do rigid connection and we're going to do semi-rigid. Now, for the rigid and the semi-rigid, we're going to do here is a step-by-step on how we're going to do it on ETABS, how we're going to do the analysis. We are going to create the joint link element. We're going to assign the rotational stiffness, and we're going to insert the link at the joint location of where we have modeled. And then we're going to apply loads. We're going to apply the dead loads and the live loads, and we're also going to incorporate the load combinations. After that, we're going to run the analysis, and the failure mode identification. We're going to, under failure mode, the results we're going to get is under joint rotation, joint shear, axial, and tensile forces. Here is a screenshot of how we are going to do how we're going to incorporate our semi-rigid joint link. As you can see, now for us to achieve our specific objective number 2, which was the effect of joint design and bracings on horizontal stiffness and slenderness, we're going to do apart from doing the bracing system, the joints, we're also going to add bracings onto the model. So the types of bracings that we're going to add is the X bracing, the chevron, which is the V or inverted bracing, and we're also going to do the K bracing. Now, the procedure for modeling that is we're going to insert a new frame element that is for the bracings, and we're also going to to do the analysis. We're going to do under ETABS, we're going to apply the lateral loads, and then we're going to do the analysis, and then we get the expected output. Now, under drift and slenderness checks, these are the checks that will be done by the software, and these are the incorporated formulas that are going to be used for doing the checks. Here is a slide on how we're going to incorporate our bracings into our model. So here's a procedure of how we're going to do it. I'm going to do that. Now, for our third specific objective, which is the evaluation of the maximum safe stacking height, we are going to do the vertical load accumulation analysis. So for this specific objective, we are going to use semi-rigid joints. We are going to do for the maximum safe stacking height. For us to obtain that, it is a combination of the analysis on joint rotational stiffness, lateral displacement, and the global stability and the accumulated joint rotation. So the model for stacking height that we're going to use in ETABS, we're going to create a base container module, and then we're going to assign the semi-rigid joints into our module. We're going to budget of what we will need. Here are some of the references that we used. Thank you very much.
Thank you. Now, before that, what were the previous comments and how have you addressed them?
So you were told that the topic is too general, so we change it to that. And we were also told to our study should just concentrate on joints. And we were also told to look at the horizontal stiffness and slenderness and also bracing. And we were also told to look at the stacking height.
Were you told or you advised?
Oh, advice, sorry.
Thank you. So you have addressed those comments?
Yes, we have addressed the comments.
Thank you. Dr. Winnie.
Okay, thank you very much to the students. I think I can see some improvement from the concept presentation. But on this slide you're sharing on the topic,
Yes.
a study, you may need to remove some of these words.
Okay.
Yeah, I'm not saying the topic is wrong, but please reword it. There are some maybe words which are not necessary. So I just wish you keep to your plan, as you said, but the time plan, can I just comment on your time plan? Sorry, I thought you had 4 weeks, but 3 months. It's okay. I wish you all the best. Thank you.
Thank you. Any other questions?
Okay. Dr. Gadimba, please come.
Right. Thank you. And thank you for that presentation. Now, in slide number 4, this is more theoretical than a technical aspect. What is the difference between the loading you are considering versus what the containers were designed for?
Yes.
Pardon?
What is the difference? The second statement, containers are designed for vertical stacking, not for building loads.
The way the original design for containers for transportation, for cargo transportation, and not for building purposes.
Yeah, but I'm talking of the loads because you see, the loads, the containers contain goods which have got some weight, right?
Yes. Yes.
And you're also going to consider some dead loads and some variable action, right?
Yes.
So that statement to me is not very clear until you clarify it.
either way, whether it's as a container or it's as a building, it's still having some gravity loads and lead loads and life load and so on and so forth. So you may need to clarify further as you do in a subsequent presentation. Scope and limitation should come after the objectives. I think there was the flow of your work somewhere. Yeah, then you went to objectives. Okay. Then when we are in the objective, can you look at the main of to carry out a detailed study? When you bring in the word to carry out, that's a method. It's a procedure.
Okay.
Yeah.
Yes.
So you are just assessing or evaluating the behavior. Okay, it's not carrying out. When you are assessing the behavior, evaluating the behavior, or you are determining the behavior, whatever it is, that as long as it's investigative word, then there is the method.
Okay.
That's when the word carry out, to measure, to calibrate, all these are methods. Now, objective one seems to be two parts, which is not right. To analyze and compare, the specific objective should be just one part.
One part.
You are analyzing and comparing different types of container connections.
Yes.
You can't have it as analyze and compare. You can't. And number two,
yes.
By the as you are analyzing, what are you determining?
We were determining which type of container structures.
No. I'm saying we are talking about the connection.
Yeah, which type of joint is more effective in containers construction as you
How will you measure the effectiveness? There must be a measure, a quantity that will tell you this is more effective.
That was under methodology.
Those are when you hear the word specific objectives, the specific parameters, you must have a quantifiable, a measurable parameter. Otherwise, it's not smart.
Quantifiable.
Okay, quantifiable or measurable. There's something you are measuring. In assessing, the title you are saying is assessing what? Analyzing, and you are telling me to determine which one is more effective. In determining what is more effective, there are parameters you are quantifying, and you are saying, oh, this is higher than this. This quantity is lower than this.
This one.
Yes, that's what differentiates specific objectives from the main objective. The main objective can be general. You don't have to specify the parameters.
Okay.
Okay.
Yes.
So please check that. Then your research gap. The word limited is a sellout. You can't say limited. The moment you say limited means there is a study already existing.
Okay, wording. Yes.
Limited. It means there might be two studies. But what if it's just one study, which is exactly what you are doing? Would you still conduct a study and say only one person have done that work, so I am repeating?
No.
Even if only one person have done that study, read that work, identify the gap from that work.
Yes.
Okay?
Yes.
Identify the gray areas that need clarification from what they have already done. So this research gap, please check, not limited. Conceptual framework, let me see it. I think I might have missed it. You had it, but yeah, I wanted to see the parameter, like objective one, you see. Joint shear and joint rotation. So I'm going to see the value of rotation, theta, shear V. Okay.
Yes.
So these are the parameters I was saying that they are in the specific objective one. Second one is the stiffness, horizontal stiffness. Stiffness of what? Of the structure. Anyway, these ones, but there's something that is missing. You have mentioned the parameter, but what is varying? What is it that is being varied? Because they are variables, right?
Yes, they're variables.
Sometimes we have like percentage are varying. We have like the length is varying. The diffraction values are varying as we continue applying the load. Maybe the load that I'm applying is varying, so that on the other on the dependent variables, the deformation will vary.
Yes.
Okay, so it can be improved. It's okay the way it is. I mean, it's reasonable, but you need to show the varying. What you go and measure as as will be varying at different stages of loading.
Okay.
One of them is already I'm pointing out, the level of loading will vary. Maybe even the nature of the load. There's one maybe you'll have just vertical load, the other one maybe you introduce the lateral force.
Yes.
Okay.
Yes.
Yeah, so you need to specify that in the conceptual framework. So
Yes,
the
thank you.
methods, in the method you are just, there was an area you just started showing us a screenshot of the software, what you are doing there.
Yes.
Well, it's okay, but what is more important is
yes.
For each procedure, you show us the parameters that you are determining at each step.
Okay.
That is what is more important.
Okay.
Because even when you are going to present your, I'm not saying you cannot show a sample. You can show a sample.
Yes.
But this software, which software is this? ETABS.
ETABS software. Yes.
Yes, you might be in ETABS, but for me, I'm a maybe like a Study Pro guy, right?
Okay. Yes.
So this is neither here nor there. It's just a software that you're using to assist you, unless if your study is on softwares. But for you are using that tool. For us, we are more concerned about the output, the parameters that you are measuring, the input parameters, the output parameters. Okay.
Okay.
Good. Those are my comments here. Thank you.
Thank you. Mute your mic and stop sharing. Who is coming next?
We are coming next.
Okay. Okay, thank you. Lewis, eh?
Yes. Good afternoon. Our proposal is on the assessment of durability characteristics of special concrete structures using sodium silicate self-healing technique in the coastal region. My name is Les Gitonga and my partner is Cephas Namachanja, and we were supervised by Dr. Engineer Brian Odero. So this is our overview. The coastline of Kenya houses critical infrastructure that facilitates over 90% of the country's international trade. Special structures such as dams, piers, bridges, quay walls, and water tanks are exposed to a harsh, aggressive environment, such as alternate cycles of wetting and drying, tidal action, and our focus, chloride action, which mainly leads to the deterioration of these structures from the formation of microcracks. The microcracks act as direct pathways for chloride and other deteriorating substances that penetrate the concrete cover, enrich the steel reinforcement, and corrodes it. So existing strategies such as improving the mix or using surface protections, yes, they are protective measures, but they don't autonomously repair the damage. Our proposed method is self-healing using sodium silicate. It will involve saturating silica gel granules and our carrier with sodium silicate and placing them in the concrete. The reaction between sodium silicate and calcium hydroxide will yield calcium silicate hydride gel, which will act as the sealant for our cracks. So for our problem statement, microcracks act as direct pathways for chloride ingress. Chlorine corrodes steel reinforcement. Corrosion causes spalling, widens the cracks, and eventually compromises the integrity of our structure. Some of the problems faced are water infiltration through foundation cracks, which leads to erosion, seepage of contaminated soil water, and settlement problems as there is loss of soil support. In water structures, there results in water loss and contamination of water quality. For study justification, there is little data that exists for the application of sodium silicate using silica granules, specifically to the Kenyan context. The proposed system is intended to address the initial stages of deterioration by addressing the microcracks the moment they form, as opposed to emergency fixes where a visible form of deterioration must be seen. It also offers major cost savings by extending the structure life, and it outperforms some of the current solutions. For example, epoxy injection is costly, temporary, and it requires damage to fabric. UV exposure also to surface coatings degrades them over time, which will require application every 5 to 10 years. For our objectives, our main objective is to determine the performance of autogenous self-healing technique and the basic material properties of the concrete mixes used in special structures as a basis for evaluating chloride ion ingress. For specific objectives, we are going to determine the basic and mechanical properties of the materials for use as a baseline on the study of self-healing concrete using sodium silicate, to determine the formation and development of microcracks under controlled loading and chloride conditions, determine the durability and effectiveness of sodium silicate in management of microcracks and chloride penetration in concrete, and to determine and analyze a mathematical equation for the relationship between crack width, healing time, and percentage of strength change. For our scope, we'll evaluate and base our study on concrete class 20 or 25 that we'll prepare using standard PPC cement, standard aggregates, and sand. Our self-healing function will be carried out through integrating silica gel granules filled with sodium silicate with concrete matrix. We will cast concrete molds of 150 millimeter by 150 millimeter cubes. We'll cast an average of about 15 molds. 3 molds will act as our control experiment. 12 molds will vary the amount of healing agent by 0.5%, 1%, 1.5%, and 2%. We'll also perform mechanical and durability tests. We will simulate a chlorine condition environment where we will expose our pre-cracked molds through a repeated cycle of partial immersion in 3.5% salt water, followed by air drying periods. The entire testing procedure will span a period of about 6 weeks. For our limitations, we have the limitation of project budget, which our project budget is limited. It will affect the number of molds that we can cast. We are unable to use expensive specialized materials such as biological healing agents, and we don't have access to high-cost analytical equipment. For our time period, we'll base our healing performance for a 40-day post-healing period. We will also have issues with durability because we can't span our study for long periods of time.
Okay, for our literature review, the first literature review, the study area was the encapsulation in porous carriers. Now, in this, we found out that they used expanded perilites as their carrier, which affected the compressive strength of concrete when it was inside the concrete matrix. So, as a change, we are going to use a different carrier, which is the silica gel granules. For the second one, which was the bio-based material for marine environments, their study evaluated healing mainly through observing crack closure and permeability. And for us, we're going to evaluate the healing through strength recovered. And then for the third one was the review of the microbial self-healing. For them, they use bacteria as the healing agent, which is majorly affected by environmental conditions such as pH, temperature, and moisture that affected the repair efficiency. And lastly, we looked at the self-healing of concrete using micro-encapsulated epoxy resin. And by use of epoxy resin as a healing agent, their study, yes, it achieved the restoration, but it was, but their capsules ruptured, which majorly affected because of the lack of durability in terms of real-world conditions. So, based on our literature review, we had 2 research gaps. First one was the available research does not solve the possible problem of strength reduction in concrete because of the introduction of the healing agent carriers. The second one was inadequate data on how porous carrier systems perform and protect the healing agent under real-world coastal conditions, such as chloride ingress and wet-dry cycles. This is our conceptual framework depicting independent and the dependent variables. Methodology, based on our first objective, we're going to conduct slump tests to test the workability of the materials, sieve analysis, and specific gravity according to the standards. This is the total test we perform. Based on second objective, we're going to conduct a splitting tensile test to induce the crack. Based on our third objective, for durability, we're going to conduct corrosion monitoring, subtivity test, and compression strength test.
These are showing examples. Our fourth objective was based on a mathematical model relating between crack width, healing time, and percentage change. We're going to perform a regression analysis and validate our model. So these are the equations we're going to use: healing degree of our cracks and the recovery rate strength of compressive strength of the concrete. Now, as a result, we expect to have the basic and mechanical properties of our aggregates, sand, and cement that are going to be used in the study of our self-healing. We're going to look at the formation and development of microcracks under the controlled loading and chloride conditions. We're going to get the determination of durability and effectiveness of sodium silicate self-healing techniques in managing chloride penetration. And lastly, we are going to have the relationship equation between crack width, healing time, and percentage of strength recovered. This is our project's timeline, our budget costs, and our references. Thank you.
Thank you. Now, what were the previous comments?
So previously, we were told to work on our title. We were told to include the healing agent that we're going to use, which is sodium silicate, to include this, and as well, we are told to reduce the number of words, which we reduced to be less than 18. Secondly, we were told to work on our objectives, to arrange them in the order in which we're going to perform them in the lab, and as well, our first objective should be based on the material. And also, we're told to make our presentation less wordy. So that's all the changes we're told to make.
Thank you. Okay. Dr. Winnie.
Okay, thank you for the presentation. On the topic. You said you were taught to reduce the number of words. Have you reduced?
Yes, we reduced the number of words to be less than 18.
18 is a threshold?
So what we were advised, yes.
So you are assessing the durability of special concrete structures.
Yes.
Which I didn't hear any special concrete structure mentioned in your presentation.
In our background information here, we mentioned what our special structures are. Basically, the structures that are constantly exposed to the marine environment, for example, dams and bridges. Those are what we mean by special structures.
You can have them in the background, but in your study, how are you going to work on them? Still go to that slide on the topic.
Okay. So now, for example, in the methodology, during the curing period, it's going to be exposed to cycles of wet and dry cycles, and the water is going to contain chloride, so that it simulates the coastal conditions, the chloride conditions.
I think when you mentioned the special concrete structures here, it shows that you're going to work on them.
Okay.
Okay.
Yes.
So maybe you can rephrase it and maybe say concrete exposed to those conditions instead of the structures, because once you mention the special concrete structures in the topic, we expect that you are going to work on those structures, and we will even see some, even maybe experimental simulation. We expect to see some. Okay.
Okay.
On the objectives, what did we say from the concept presentation about the main objective?
Sorry?
In the concept presentation,
yes.
What was the comment about how the main objective should be? Do you remember?
You told us that, okay, you focus on specific objectives. You told us they were not in order of how they're going to follow each other.
Yeah, but you also mentioned that our main objective should also look like. What did we say? Even what you told the other students, or you were not listening?
I think I might have missed that.
We said the main objective should look exactly like the topic. And your objective and topic, the words are very different things. Is that okay?
Yes, that's okay.
So please rework on that.
Okay.
Those are my major comments. But still on the methodology. So on the methodology, don't move from the objectives.
Oh, sorry.
You said you're going to work on durability.
Yes.
Okay, so objective 3, it's okay. So please work on the topic and objective so that they can align with your work.
Okay.
Thank you.
Okay, thank you, Dr. Dr. Kadimba.
All right, thank you, Chair. Just a few to add on what Madam Winnie was talking about the title. Yeah, I think you just mentioned, you just say concrete, exposing marine environment. And the title seemed to be a bit blurred. I think you have been advised accordingly. Now, when you look at that title, your focus is on durability. But when I get to your objectives, you are not only focusing on durability, you even have mechanical properties, is it?
Yes.
You know, the title is the one that is supposed to be broad. So title seems like to be just a small portion of all that you are covering. So revise that. Okay. Then again, your objective 1, 2 are there. You can be saying to determine performance and the basic material property. No. There are things which are in determining the or assessing the performance. I mean, it's obvious that basic material properties come in. Concrete mix design, whatever it is, comes in. So you don't have to state it explicitly in the main objective.
Okay.
Okay.
Yes.
It's the same. Look at objective 1 to determine the basic and the mechanical. No, it's not 1. Objective 2 to determine the formation and development of microcracks. No, this is a different concern. You are telling me you want to study about crack initiation and propagation in this study.
Okay, we were just going to induce the crack and then evaluate the performance of the self-healing agents.
So, but you are saying to determine the formation of microcracks.
These were, okay, here we were to use the splitting tensile test to do that.
So what I wanted to, I thought your studies on crack propagation, it's a whole new world of another studies about cracks, and we have fracture criteria and all that. I didn't think that is the direction you want to take. So I don't know how that objective will be reported in terms of results. You might need to look at it. If it's just a matter of saying you're initiating a crack and this maybe it's in a method so that you can determine maybe the mechanical properties, then it's just captured in the objective of mechanical properties. Maybe you could want to talk of maybe study on cracked specimens. Okay. But crack formation and development, you might really need to think deep about it, whether it's achievable within your scope of work. And then basically number 4 is the same as what I meant for main objective. You can't have 2 parts: to determine and analyze a mathematical equation. How do you analyze a mathematical equation? How do you determine a mathematical equation? Basically what I think you're doing, maybe you are developing. Unless you want to tell me you are analyzing an existing mathematical equation for its suitability.
No.
So look at that.
Okay.
Yeah, I think the rest have been erased, so I stop at that. Thank you, Chair.
Thank you. Stop sharing.
So good afternoon. My name is Margaret, and my colleague here is Hekame Wangusi. This presentation is on the performance of eggshell powder as a partial replacement of lime in the stabilization of red clay soil under the supervision of Dr. Winfred Mutungi. Second slide, background of study. Red clay soils are widely used as foundation in subgrade materials. However, they exhibit high plasticity and low shear strength, which leads to poor performance in construction. Lime is commonly used to improve these properties, but eggshell powder, which is rich in calcium, offers a suitable alternative that can supplement lime. Problem statement. The problem addressed in this study is that lime-only stabilization can lead to excessive stiffness, and brittleness in red clay soil. In addition, lime does not fully eliminate shrink soil behavior and sometimes results in limited reduction in plasticity. This creates a need for an improved stabilization. Study justification. The research supports suitable engineering practices and green construction initiatives. It also contributes to knowledge on alternative stabilizers for problematic clay soils. This study promotes environmental sustainability by recycling eggshell waste and reducing landfill disposal. It lowers costs for construction since eggshells are locally available and inexpensive. Our main objective of this study is to evaluate the performance of eggshell powder as a partial replacement of lime in stabilizing red clay soil. We have 3 specific objectives, which is to evaluate material characterization, to evaluate effects on plasticity and compaction, and also to evaluate strength characteristics of stabilized soil. Scope and limitation of the study. The study focuses on laboratory-based stabilization of red clay soil. Tests include Atterberg limits, the CBR test, and the UCS test. Field implementation and long-term durability studies are not covered in this research. Our literature review. Several studies have shown that waste materials containing calcium can improve the engineering properties of the clay soil. Just to mention a few, we have Hinga, whose study focus was stabilization of red clay soil using natural gravel and lime. And he found that there is improved subgrade strength for rural roads. Then, but the challenge was lime was costly and there was so much carbon dioxide emissions. Then you have Joel Kimarai, who used sorghum stalk ash as partial replacement of lime. There was reduced demand and improved subgrade properties, although lime was still dependent for this. Is practical. So Aknui et al. The study focused on water-based stabilizers in soil improvement. There was reduced plasticity and improved UCS and CBR values. Then we have Hassan et al. His study focused on use of waste materials in construction, including eggshells. He concluded that eggshell powder has significant potential as an eco-friendly additive due to its high calcium carbonate. He did not provide experimental data on mechanical performance, nor did it address optimum replacement ratios. Conceptual framework. We have the research gap first. Despite these findings, studies have used eggshell powder as a standalone and primarily focused on non-calcianized eggshells. There is also no clearly established optimum replacement ratio for local red clay soils, which this study seeks to determine. Then we have the conceptual framework. This conceptual framework shows how lime content and eggshell powder content act as an independent variables. Soil properties, moisture content, curing period, and the compaction method, they act as the mediating factors, while plasticity index, maximum dry density, optimum moisture content, UCS, and CBR are independent variables.
The methodology overview, we are given material preparations, lab testing, and data analysis of what will be carried out. Materials used in this study include red clay soil, hydrated lime, and eggshell powder. These materials are selected based on availability and their relevance to soil stabilization. Eggshells are collected, washed, oven dried, heated and to convert calcium carbonate to calcium oxide and ground into fine powder. The powder is then sieved to obtain a uniform particle size suitability for laboratory testing. A control sample containing 0% eggshell powder and 6% lime is prepared. Lime is then partially replaced with eggshell powder at 10%, 20%, 30%, and 40% to assess the performance at different replacement levels. Material characterization tests carried out include particle size distribution, Atterberg limits, moisture content, specific gravity to determine the basic properties of soil before stabilization, and we'll use according to the standards that are used in the lab. Plasticity and compaction tests are conducted on treated soil samples using Atterberg limits and the Proctor compaction test. And the standard compaction test according to AASHTO T99 to evaluate changes in soil behavior. The strength tests are carried out to determine the improvement in strength of the stabilized soil, which indicates the effectiveness of eggshell powder lime blends, and we'll use the various formulas that are given in the books. Expected results. The expected results include improved plasticity characteristics, enhanced compaction properties, increased strength, and identification of the optimum eggshell powder lime mix ratio. We have our project schedule, which will run from February up to June. Then the budget of our project is given as below. Eggshell collection 700, lime, then also collection of red clay soils, consumable, sample prepping, including the manual handling, technician support, curing materials, printing and binding, and contingency, which will all sum up to 10,000. These are the references used in this study, including textbooks, journals, and standards that guide the research. Thank you.
Thank you. Just on this slide.
Yes.
What do you mean by click to add title?
This part.
On this whatever slide.
We didn't put any title.
So
we forgot to rectify that part.
Yes.
We were supposed to rectify and put like a blank page, but it might have slipped our minds.
Why?
We'll correct.
Yes?
We'll correct on that.
Thank you. Let's go to your budget.
Budget. Okay.
Now budget. When did you draw this budget?
We had done it before even the proposal.
When?
The first time we presented.
We approved this budget last year. That's last year.
Yes.
We approved this budget.
Yes, it was approved.
What do you mean by technical support, technician support worth 3,000?
We went to see a technician.
Yes.
In the school lab, and he told us we can do the project, the testing and the burning using the furnace in POW. So they said we have to give them something.
So you award them all 3,000, which is a third of your budget. Margaret.
Yes.
That's why I was asking you, when did you draw this budget?
During the first
That
presentation.
one is impossible.
Okay.
That one, hey, but you are charity, very much charitable.
Oh, because he
Why
said
did you include your supervisor here? Now that you are awarding people.
it's because the technician said we have to buy 2 pots to burn our eggshells, which goes for 1,000 each.
So you give them 3,000 for supervising you, assisting you during tests.
We should have added purchase of the pots.
Correct that, huh?
Okay. Okay.
Hoping that your partner is okay, or maybe that's a way of evading questions.
No, she's sick.
Yes, no problem. Slide number 16. Now, before this, what were some of the comments previously?
It was about the objective or specific objective. We were told to omit our third objective then.
Our third objective was to determine the optimum replacement of the ratio. Yet Dr. Mutua told us like we should omit that and break our specific objective number 2. It becomes 2 and 3.
I see you people, your problem is that you are coming late in the presentation. Kama tumechoka. But anyway, no problem. Now, any other comment that you tackled?
No, it was just on the specific objective.
Okay, so let's go to slide 16. Is it here?
Yes.
The next one, 17. Somewhere you're talking about, maybe it's there. You were talking about eggshell. There's somewhere you wrote equation, or you are demonstrating how you will do the work. Eggshell plus 0%. 0% eggshell plus some 6% here. Number 15, yes. Tell me, what is the science here?
The science in the first point or the second point?
Yeah, both of them. The first point?
For the first point, we use that as a control sample because it's something that has been done before. So now we do this. For the second point,
yes,
we are trying to get the optimal proportion of eggshell powder and some lime and the clay soil.
Yeah, I'm on the second point.
Yes.
You know, eggshell is more of it is calcium.
Yes.
And lime is, of course, calcium.
Yes.
Huh?
Yes.
You are saying yes. Now, are these not the same thing? Same chemical content?
They have the same chemical components, content. But for lime, it's getting way more expensive. So we are trying to reduce the cost. And again, for eggshell powder, it has the same chemical properties as lime, even though when done alone, it will be less reactive. So mixing it with some lime, it will reduce some costs and also reduce environmental pollution.
Yeah, exactly. That last point is what I was aiming at. Environmental pollution or degradation, I think probably is the major thing with regard to that second point.
Yes.
It's not about cost. It's about degradation of the environment. That is why you are considering eggshells.
Eggshells.
Yeah.
Yeah, it's not about cost there, in my opinion.
Okay.
Now, next is where are you going to get eggshells from?
We have been doing like a survey, and so far there are 2 supermarkets that are willing to give us the eggshell waste, which includes the Mathai's supermarket, they produce almost around how many? 300 per day, and 300 eggs per day. And we also contacted Juja Ecomat, and also
think about the question of the source.
Yes.
The source. The source is important with regard to your work, and the quantity required.
Yeah.
The quantity, you just showed us a photo here, which is very simplistic. But when now comes second semester, you are looking for these eggshells, you will not find them. So think about it and find a way of addressing the source and the availability issue.
We already collected some, and we stopped collecting like some days ago. So that we have this team after exam. Yes.
Also, you have enough quantity, or
we haven't reached like the target quantity, because when we had talked to like the lab technician, he said for 1 kg of eggshell it will produce like 100 grams of the eggshell powder. So we're targeting something like either around 9 to 10. So if it's more, we'll have like more.
10 what? 9 to 10 what? Kg?
Kg, yes.
Yeah, that is my point. The availability and the quantity. And here we are talking about ash.
Yes.
Which you will get after sieving.
Yes.
Yeah, after sieving. Yeah. And that is not easy, my friend. So think about it.
Yeah. Okay.
Tied to that, how will you get the ash?
We already talked to the lab technician of Pausti. He said he'll help us burn the eggshells.
The ash, the eggshells.
You are depending on lab technician. If they fail you,
we'll get an
anyway. It's okay. Let's go to slide number 4, 5, and 6. 4, 5, and 6. Yes, look at those. Number 5. Number 6. Can you see something unusual? Slide number 6. Yeah. You see, you guys, you don't know how to do slides. You are just writing minute things. You have a big slide, but now the proportion of your text within the slide is like almost 10%, 20%. That's not how it's supposed to be.
Okay.
The slide need to cover at least 75%. If you find yourself doing things like in slide 4, click slide 4. Yes. It is so squeezed at the center. Margaret.
Yes.
Iko shida na wewe. You mean you couldn't do this better?
We can.
Please,
Yeah.
Thank you. Dr. Gadimba, do you have something for them?
Yes, for the studies that we've found, they've been using eggshell as a standalone, and also some haven't been getting like optimum ratio, but mostly basically it's just as a standalone. So like ours, we want to partially replace lime in it.
It has not been done before.
Like let's clarify on that. It's not like they haven't been getting optimum. From their studies, there are those grams that they use, so we'll be using that as a reference, and also to now it will assist in our project. Okay. Yes. Okay, noted. Yes.
Okay. Okay. Oh yeah.
Yes. Okay.
Okay. Yes.
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 Yes. Yeah.
Yes.
Labor work.
Okay.
Mm. Oh, when we're talking about that, he mentioned, yes, we'll be doing it, but he's going to be the one who is guiding us on, especially when it's coming to the burning. He said that students aren't like allowed to burn alone. So someone has to be there to supervise, and someone who they know. Okay. Thank you.
Thank you, Daktari. Margaret, hiyo point ni kali sana, uitoe.
Sawa.
Dr. Winnie, something for them. I know you have been working together.
Yes, thank you very much to the students for the presentations and to the panelists for the comments you have given them. I hope you students use to improve your work, but I will not fail to mention on this slide on specific objectives. What happened? You went and removed them.
No.
What is this? Somebody cannot understand what we are doing. It's very if I said you don't be wordy. Objective should be complete. Is that okay?
Yes.
So please, what are you evaluating the effect of what on plasticity and compaction? What are you evaluating for strength? What? So please make your objectives complete. Don't remove work and then your things don't make sense. Thank you.
Thank you.
Thank you. Take a note. Otherwise, it was a good presentation. And yeah, thank you. We appreciate.
Thank you.
Next. Who is coming next?
Yes, it's us.
Yes, there you are. Go to the first slide, the first number 1.
Oh.
Carry on. Carry on.
Okay. I'm sorry, please allow us to share with another application because this one is just going downwards so that we find one that's going to the next one.
Okay.
Oh, they are moving downwards. Okay.
Scroll.
We want to move sideways.
Sideways or down.
Okay.
So number.
We have to. Okay. Yes, we found out how to work it out. Thank you so much. Yes, good afternoon. Our research topic is performance. My name is Beth Mawia Kilwenge, and my partner is Ngonga Yukabeth Agnes, and our research topic is performance of lateritic soil blocks modified with lime and microsilica. Our supervisor is Dr. Winfred Mutungi. Background information: lateritic soils are widely used for low-cost construction blocks in tropical areas because they are readily available and cheap, but they often have problems like low compressive strength, high water absorption, limited durability, and this may limit their construction application. Therefore, chemical stabilization has been adopted to counteract this, and lime is one such additive that has been adopted. It improves soils through pozzolanic reactions. Yes, microsilica, which supplies high silica fume, when reacted, is also used to supply additional silica, and when it reacts with lime, it forms the cementitious calcium hydrate, and this is through pozzolanic reactions. But these pozzolanic reactions, they're usually affected by factors like pozzolan composition, lime content, particle size, curing time, temperature, and our research aims to investigate whether combining lime and microsilica can improve the properties of lateritic soils, and also if the mixing temperature has an effect on early strength development and the overall strength of the lateritic soil blocks.
Onto the problem statement. As observed in the background, we get to understand that unstabilized lateritic soil blocks normally exhibit characteristics such as high water absorption, low strength, and poor durability, which in fact might cause structural failures, causing it to be a risk. So as we will be stabilizing the lateritic soils with lime, which causes slow early age performance, which limits the reliability of the blocks in construction, we will supplement it with another pozzolanic material, And in this case, microsilica has been proposed. Objectives, the main one being to evaluate the performance of these lateritic soil blocks once they have been modified with lime and microsilica. On to the specific objectives. Our first one will be to characterize the physical and chemical properties of the lime and microsilica. And then thereafter, we will determine the basic and physical properties of those, and then examine the effects once we have mixed the lime and microsilica, which will definitely modify its properties. The third one will be to investigate the influence of the mixing temperature on the strength and performance of the modified soil blocks. Then finally, we will assess the durability of the lateritic soil blocks that have been modified with lime and microsilica.
Scope of our study, we will be using lateritic soil from GQuat funds, and the lime and microsilica we will obtain it from local manufacturers. Modification will treat our soils with lime and microsilica. I'm sorry, kindly, please allow us. I don't know if you can see the entirety of our slides because from our end they've been cut out. Hello?
Yeah, we can see imekatika.
Should we in another format or we just go on?
Just go on and finish.
Yes, modification will be treating lime with we'll use 6% lime, and the microsilica percentages will be 2%, 4%, 6%, and 8%. Temperature considerations, our mixing temperatures will be varied. We'll have 25 degrees, 45 degrees, and 65 degrees Celsius, but our curing temperature will remain constant. Our tests are laboratory based, and the lateritic soil blocks that we'll use are 290 by 140 by 100 millimeters. For our strength indicator, we'll use the compressive strength test, and for our durability indicator, we'll use water absorption and the wetting and drying cycles, followed by UCS. Literature review, we reviewed some scholarly works. For example, there's this study by James and Rajasekarana on lime and fly ash. They found that lime and fly ash can be used to stabilize blocks, and they met the Indian standards. But in our critique, we found that the pozzolanic, although they show how effective the pozzolanic materials are, they did not study anything to do with temperature variation. We also have another study by Lee et al. This one they did cement and microsilica, and although they showed the effectiveness of microsilica in that it increased strength by 81.75%, but there was no assessment of, they did not assess temperature variation, and also there was no assessment of combination with lime. These are more findings from the literature review. Yes.
On to our research gap. As observed in the literature review, we got to find out that lime and pozzolanic materials significantly improve the strength and durability of these lateritic soil blocks. Though effective and powerful. Yes, influence of temperature mostly has been in the curing stage, but if you check most studies that tend to highlight mixing temperatures, we have not managed to find any in our literature review. So Combining these two, we get to understand that when we use a combination of lime and microsilica and use mixing temperature variations as a catalyst, we're able to affect the mechanical and durability performance of our lateritic soil blocks.
Conceptual framework. We have the independent variables and the dependent variables. For example, in our objective 1, lime and microsilica are the independent variables, and the dependent variables are physical properties and chemical properties. We also, in objective 2, we'll have the neat soil, and then also the neat soil plus lime plus microsilica as the independent variables, and our dependent variables are physical properties. In our objective 3, lateritic soil blocks that are 290 by 140 by 100 millimeters that have been made from lime, microsilica, and lateritic soils with varying mixing temperatures. And from this, our dependent variable is compressive strength. And our fourth objective, the independent variable, is water absorption conditions, time and wetting and drying cycles with curing. And then the dependent variables is the compressive strength after this, the curing, and water absorption rate.
The conceptual framework gives us a glance on what our methodology will be, aligned with, of course, our objectives. And we get to see the first one as we characterize the physical and chemical properties of lime and microsilica. We get to see for lime, we will find out some properties such as the moisture content, the calcium carbonate equivalent, the chemical composition of this lime, and also for the microsilica, we'll also get to understand properties such as the bulk density, the particle sizes, and the minimum surface area. For the second, for the methodology, for the second objective, as we classify these lateritic soils and examine the effects of the additives, we'll carry out some of the tests such as Atterberg limits, soil classification, and compaction test, and the Atterberg limits. Okay, for objective number 3, sorry for that. For objective number 3, as we investigate the influence of mixing temperature on the strength of our stabilized lateritic blocks, we'll get to see its performance on the compressive strength test at the JQuat lab.
Our objective number 4 will be to assess the durability of our lateritic soil blocks, and we'll do it through the water absorption test. And then we'll also do wetting and drying cycles followed by compressive strength tests. These are our references. This is our budget. I'm so sorry. I don't know what's happening. And then our work plan. Thank you so much.
Okay, thank you. Thank you. What were the comments last time?
The comments that we had last time,
we were to check on our title so that we align it with our general objective. Our general objective initially was bringing out strongly the catalyst, which is the variation in mixing temperatures, but we were told to align it as a specific objective, so we were supposed to check that in accordance with our title.
We also had another comment was for our objective 1 and objective 2, we were told to make our objective 1 on characterizing the physical and chemical properties of the materials that we'll be using, which are lime and microsilica, and then to combine our previous objective 1 with the objective 2, which became determining the basic properties of the lateritic soils, and then the lateritic soils after they have been modified. We also had a comment on how we would ensure that our mixing temperature remains. For example, if it's at 65 degrees Celsius, how would we ensure that this mixing temperature remains at 65 degrees Celsius? And we chose to have that as a limitation. Yes, we had those 3 comments.
Okay, thank you. Now, slide number 13.
believe it is 13. What is this?
The conceptual framework.
Who taught you this? Conceptual framework is a diagram.
Okay.
Is this a figure? You have given a table.
No,
Is this not a table?
it is a table.
Why?
We assessed and saw that this might be the best way to present the work, but again, it is subject to your guidance as a panel.
Conceptual framework is a diagram showing the connection between independent and dependent, with an arrow indicating from the independent to the dependent for each of the 4 objectives which you have. So you need to check on that.
Okay, thank you.
Research gap, sorry. Number 12.
Research gap.
Number 12. Oh, anyway, thank you. I think that is it from my end. Dr. Gadimba.
Maybe nothing much to add. Just a small part that I think you can improve on your work. The problem statement. I just want to ask you the theoretical question. Problem statement.
Okay.
The second box, you are saying line causes slow early age performance. Why?
From some of the studies that we have gone through, we tend to understand that even after the 28 period for curing, the blocks that have been manufactured from lime still gain strength even after 28 days. But in the initial days, it's just, yes, it tends to strength gain way beyond the 28 days.
No, I'm not asking actually empirical literature. I'm asking from theory. I believe I'm the one who taught you civil engineering materials 1.
Yes, you did.
We talked of pozzolanic materials.
Yes.
And we had a definition of what is a pozzolan. And the pozzolanic reaction, as opposed to ordinary Portland cement.
Yes.
Because I'm wondering, if you're saying lime, the strength development is slow at early age. Are you bringing in a pozzolanic material to solve that problem?
Okay, I think that was brought out very strongly by the fact that we are trying to use a catalyst so that within...
Which catalyst?
The effect of mixing temperature.
There is furthermore, the effect of mixing temperature on early strength. Is it one of your variables in the objectives?
Yes.
Can you go to the objectives? Go forward to the objectives. Which objective is that? Maybe I missed it.
In objective number 3.
Mixing temperature on the strength. Then your main objective on the title are not reflective. If temperature is a key aspect, key parameter that you are varying in your work and you're investigating, then it should be captured. It needs to be captured. But I still, in the next presentation, I would like to see the equation for the pozzolanic reaction. Why do pozzolans have the rate of strain? Okay, let me just give you the answer, partial answer at this stage. You are not going to get RS strength using pozzolans. You're not running away from lime to expect to get RS strength using pozzolans. No, actually to be the opposite. That's why for pozzolanic material, we go for 56 days and above. At 28 days, the pozzolanic activity have not kicked in. Go find out that science, and next presentation, we would like to see that equation. What happens? Why? What have to be formed first so that now the pozzolanic reaction can initiate? Okay?
Yes.
Now, the basic lateritic soil. First is characteristic, second is basic and physical properties. Yeah, that term basic. Basic. You know, basic would be physical. You can have a basic property which is physical. You can have a basic property which is mechanical. You can have which is thermal, but it's just basic. So I think the best term there is it physical and mechanical properties?
Okay.
Okay.
No, I'm just asking. I don't know whether, because you could be just checking something else, but I think here in the first step, that the first objective is where you are doing the Atterberg limits and all that. Is it?
No.
It's in the second one.
Yes.
Oh, the first one is characterization of the soil.
Yes.
The
Of the lime and microsilica, not the soil.
Okay.
Yeah.
So the second one, of course, now this is the physical and the mechanical properties, because it's where you are doing the Atterberg limits and what else?
Yes.
And what else?
We will be doing the
MDD, the natural moisture content.
Those are some of them are mechanical properties. So the word basic you could replace with the physical and mechanical properties. So
okay.
Then what was the other thing? Objective. Okay, you apologized. I wanted to say your objective are not complete, but you said it's an issue with the presentation.
Can we please change to our PowerPoint itself, because this one was the PDF one, so that it's visible.
No, it's okay. It's okay. Now you already said it's a challenge, so I can see it now in the methodology. I think it's okay. It's okay. But if you can be able to find out what was the challenge, I believe the way you are presenting now is good, because it gives us a big screen, as opposed to when other people are presenting and we have to see all the tabs, all the slides tabs on the left hand side. This one gives us a chance to see just the presentation, the slide that you are presenting. It makes it's more legible. Okay.
Yes.
One of the way of doing this is to convert your work into PDF, but I don't know why people don't like converting to PDF. Anyway, the rest have been raised, so I don't want to repeat. Back to you, Chair. Thank you.
Thank you. Thank you. Dr. Winnie, I know you are the supervisor, but maybe you may have 1, 2 comment or question.
Thank you. Thank you to the students for the presentation. And also thank you to the panelists for the comments. I hope we'll work on them, students. Let's work on them.
Yes.
On this slide you're sharing on the methodology, where will you do the chemical properties of lime and microsilica? Where will you do them from?
Okay. We also thought of the same, and we are highlighting it in the limitation. So we plan to use technical data sheets provided by the manufacturer to acquire this information.
Yes.
But you already wrote here that we'll be getting the chemical properties.
Sorry?
You already writing in this methodology, this slide you're sharing, how you'll get the silicon dioxide. I was wondering how you will get it, because you did mention.
So this is in case now we are not able to do the research in the interest of time. We had researched on ways how we can find these properties using these standards, but in case when we begin the next semester for our research and we find out that the time is limited, we may have to use the technical data sheets from the manufacturers for these characteristics, for the properties.
By now you should be knowing what we will do once next semester comes.
Yes.
It's not time of waiting for next semester to decide.
Okay.
Thank you.
Thank you.
Brian, I think group number 2 has not presented. I don't know whether they are here.
Yeah, but we called on them and they are not here. Are you there? It's called, was Michelle and Kemunto. Michelle and Kemunto. Are you there? Michelle and Kemunto.
Maybe they are not in fifth year, we don't know. Because even last time, only one member of that group presented.
Oh, so probably they remain behind.
Okay, we will report that. Thank you.
Thank you. I think, therefore, we have come to the end of our today's presentation. We want to appreciate everyone for being patient with us up to this point. It has taken a long time, since 8:15 up to now. Again, I just want to urge students so that to at least work on the comments which have been raised. Kindly work on them to change the structure of your work. As you're aware, next time we should not be asking some of the questions which have been raised today. And in case you will subject us to that, we will always remember, and that will make us form bad opinion on you. So kindly work on the comments, consult with the supervisor to make better your work. In case of any challenge, it's good to always raise so that you do your best in your research. Otherwise, thank you. So maybe any comment from Dr. Winnie before I call upon Dr.
No, just to urge the students to be prepared for the lab work or the works they're going to do on the modeling, because next semester is usually short. So they should have visualized how their work will be, how they will carry their test and their modeling, just for their better planning, please.
Dr. Gadimba.
Now, mine is just to improve the student to work with speed. Now they can start compiling the report so that, because this has been the trend, the student, the deadline of submission of the final proposal is Friday. They start bringing the report to you on Thursday or Wednesday. You should ensure that you start working on your report and you finalize it. At least you give your supervisor minimum 1 week to look at it. Okay? Then the other thing is, for my student and even for those that will be marking, if I see in the report a comment that was raised, because we are taking notes in our notebook and we also remember, okay, we might not remember everything, but I can remember part of, when I see a topic, I can remember the question that was raised. So when I'm marking a report, if it's your report, or a student brings to me for signing, if I'm marking, I'll award you very low score because I'll assume that is ignorance. It's like you disregarded the comment that was raised. We have spent a whole day here. So please, utilize the comments. Even there are those who had already prepared the draft, especially the one that I'm supervising, and you wanted to submit to me. Please, I told you, wait until you do the final presentation so that you can make comments. You can amend the document. Okay? So don't just go and keep this comment and say, that was a final proposal, I don't need to do anything with it. You are supposed to improve your report. Thank you, Chair.
Thank you so much. I wish you all the best in your exams. Read for exams and ensure that you are in control of everything. Otherwise, now we can leave at our convenience time. Thank you.